In the second part, we will talk about deterioration of raw material. After harvest, all food products risk deterioration due to several factors or mechanisms. But how does this happen? This is due to various factors like endogenous enzymes, which these enzymes act on plant tissue and cause desirable and undesirable consequences. Endogenous enzymes act on plant tissue, promoting the softening of raw material and normally their deterioration or decay. They also, thanks to the oxygen, oxidize polyphenol substance, and the oxidation of polyphenols is always related with the changes of the color, and mostly they are associated with darkening. Factors that might control the activity of these enzymes are temperature. Low temperature inhibits the activity of these enzymes, and high temperature may destroy these enzymes. Other factors are water activity, chemical additives that inhibit their activity, etc. Other mechanisms that cause food deterioration are chemical reactions that affect the quality characteristics of the food. Here we can mention a series of chemical reactions such as lipid oxidation, which is influenced by the light, by the presence of the oxygen, by the high temperature of storage, etc. Non-enzymatic darkening reaction. This is typical example here is Maillard reaction. Changes in the color due to inappropriate storage temperature, mainly due to high temperatures of storage, or even just oxidation reactions. The components responsible for the colors are oxidized or destroyed, like anthocyanin, like chlorophyll, flavonoids, that are the component or polyphenols that are responsible for the food color, thereby affecting the loss of desired color of foods. Nutritional changes or nutrients changes of food. Factors that affect the nutritional value of post-harvest foods are mainly the light, the concentration of the oxygen, the temperature, and water activity. The main nutrients are vitamins, which are the most non-stable components of food as they oxidize very quickly. For example, the vitamin C is most sensitive of the vitamins in foods. Its stability depends on the environmental conditions where food products are stored. Among the major factors of physical changes is moisture content, which is closely related to storage condition. If post-harvest products are stored in places with inappropriate humidity, high or low humidity, these conditions will immediately affect the quality of foods due to the absorption of the moisture. Biological changes. Here we can mention germination of seeds, sprouting, etc. Microbiological contamination, both organisms and toxic products, leads to deterioration in quality, endangering food safety. Damage to the raw material can occur at all the stages of their growth. The factors that affect the damage of raw materials are many, but we divide them into two main groups: external forces and internal forces. External forces include all those indicators that cause mechanical damage to raw materials, such as fruits and vegetables, cereals, etc. For example, mechanical injury results from inappropriate treatment as a result of careless treatment, use of inadequate farm equipment for a specific product, improper harvesting process such as overfilling crops by crushing products due to the overweight, etc. Damages caused by internal forces are associated with more severe consequences for food. These damages are mainly caused by changes in the temperature, by changes in the humidity or cracking of fruits and vegetables, thus affecting the development of pathogenic microorganisms in these products. And these have to do with biological and chemical reactions. Improving processing characteristics through two different methods: selective breeding and genetic engineering. Selective breeding and improving of raw materials for high yield and high quality has been carried out for centuries for both plant and animal products. Initially, great importance has been given to the appearance of varieties or individuals, while in recent years attention has been directed to various cultivation techniques based on the best knowledge of their genetics. All interventions had a primary objective: yield improvement, which was influenced by a variety of factors such as resistance to pests and diseases, sustainability for harvesting, or development of climatic tolerant varieties. But that does not mean that the quality of the raw material is overshadowed, as it has become increasingly important, especially in terms of processing. Examples that clearly demonstrate the successful improvements in the quality of raw material for processing are improved oil percentage and fatty acids composition in oilseed rape, improved milling and malting quality of cereals, high sugar content and juice quality in sugar beets, Brussels sprout which can be successfully frozen. Selective breeding methods for raw material improvement were also applied to animal products. The main purpose of using these traditional breeding methods had been to improve yields such as milk production, egg count, etc. The impact of selective breeding has also been very positive in improving the quality of raw material of animal origin. This effect is particularly evident in dairy products, where the milk has resulted in higher butter content and higher protein content. Traditional breeding programs will undoubtedly continue to produce improvements in raw material for processing, but the potential is limited to some extent in genetic aspects of each species. Although the science of genetics is working to combine genes for even greater profits, the biggest evolution has been the improvement of agricultural products. Some examples of productivity improvement, and in particular the quality of these products, are tomatoes, which do not produce pectinases, and these are for ketchup production for sauces. These tomatoes usually are strong with a good color and aromatics. Potatoes with a higher starch content, which absorb less oil during the frying process. Wheat with high level of gluten for better bread making performance. Naturally decaffeinated coffee, etc. Although the application of genetically modified products is an open discussion due to the fear for human health risk and ecological problems, their use continues to be quite spread. Storage of raw material is an important process for continuous production operations. The storage conditions of these products should be optimal to control their quality and especially to control their freshness. Some of the conditions that warehouses must meet are water impermeability, good ventilation. Another factor of the warehouse's conditions is to provide protection against infection by insects and parasites that can cause significant weight loss of the product within a very short time. Well, if raw material are to be stored in bags, they must be stored in building with a concrete floor. The bags should be placed several inches above the floor level and for example on wooden pallets and away from the walls. Raw materials can be stored also in tanks or silos made of concrete or steel. Although recently steel material is more useful because there is no transport of elements or components through the food and the material of the silos or tanks. Wholesale storage usually means of a higher investment in capital equipment, but at lower operating costs. However, storing raw material is expensive for two reasons. I mean, in economical aspect. Firstly, why we need to buy the raw material when we can get it on time. We might not spend money for buying this product when this money we can use for other things at that time, and when we need these raw material we can buy them. And secondly, maintaining and creating the proper storage conditions, for example for temperature or humidity or other factors that requires energy, and this energy must be paid. So I have to spend, so the producers have to spend for buy these raw material and have to spend for storing them. This in economical aspect, this is a little bit difficult to understand, but as we said earlier, the raw materials generally are seasonal products if we do not store them, and if we do not store them with a high condition storage, we might not have nothing at the end. So we have to work for their storage in good conditions to have the quality and the freshness of these raw materials. If raw materials are to be stored, it is essential for manufacturers to treat these products because some types of them might have poor characteristics and tend to spoil. In general, all raw materials usually tend to deteriorate during storage, and the quantity of raw materials that can be stored in the warehouse and their storage time vary for different products. Raw material can vary from country to country and region to region, and this variation must be taken into account when determining the space needed for their storage. Proper storage of raw material is not only essential to prevent physical losses, but is also an important aspect of quality control. Food deterioration during storage occurs due to three mechanisms. Living organisms such as insects, fungi, and bacteria. These can feed on the food and contaminate it. Biochemical activity within foods leading to quality reduction, such as respiration in fruits and vegetables, enzymatic browning reactions, development of rancidity in fatty foods, and the last one is physical processing because of poor handling or dehydration, etc. Storage conditions of raw materials in warehouses depends on a number of factors such as temperature, humidity, moisture, etc. Different products require different storage conditions. For example, for fruits and vegetables, they continue the respiration process even they are harvested, and this is a problem because the respiration process affects the softening of their texture. Therefore, the main purpose for this product is to change the environmental conditions like temperature or moisture, etc., in order to inhibit respiratory rate without affecting the tissue quality. Given the variability of products, even their shelf life is different. For example, onions, garlic, potatoes have a longer shelf life as their respiration rate is lower. So we can say that the rate of respiration for some agricultural products serve as a very good storage time orientation. In fact, based on the rate of respiration as well as the forms of ripening, the agricultural products are divided into two big groups. Climacteric fruits is the first one. In this group are those fruits that are harvested immature and ripened artificially at a later time. In this group we can mention bananas, apples, tomatoes, etc. And the second group is non-climacteric fruits, which fruits here should be harvested at their optimum level, such as citrus fruit, pineapples, strawberries, etc. Well, the main methods used in storage of raw material are the control of temperature, humidity, and the control of composition of the atmosphere. Temperature. Storage temperature is a factor with great performance. All biochemical reactions occurring in food products are affected by temperature changes, which not only serve as a promoter for these reactions, but also as catalysts accelerating their chemical process. Determination of storage temperature is normally influenced by the types of product to be stored. So, a good part of the products prefer low temperatures, below 4 degrees, for example. Since at this temperature the effect of insect activity is inhibited. However, the application of low temperature is not always effective because there are food products which the freezing point is a limited factor, because after thawing this product will lose nutritional value. For example, storing at low temperatures below 3 degrees would cause browning of some types of apples, and bananas will be brown too, but below 13 degrees. Storage temperature is also cost limited. Refrigerator storage is expensive, especially in hot countries where this way of storage production is very expensive. In practice, a balance has to be calculated and established that includes the cost of storage, the cost of shelf life, and risk of damage from cooling. Another method to be controlled is the humidity of the storage place. The humidity of the storage environment of raw material is an important factor, as it affects the quality of the storage product. If the humidity of the storage environment is higher than relative humidity of the food balance, the food will gain moisture during storage and vice versa. But the absorption of moisture into these products would allow the development of pathogenic microorganisms that would cause its spoilage after that. However, lowering the moisture of products such as seeds or fruits would be accompanied by cracking of their skins, and in this case we will suffer economic losses. So, choosing the right humidity for storage environment is very important. Different products have different requests to the humidity level. Composition of atmosphere. Many food products during storage have different requirements of atmospheric parameters. For certain specific products, storage in an oxygen-free environment is necessary to prevent oxidation or browning. There are other products that need the control of the atmospheric parameters through the addition of various gases, such as nitrogen or carbon dioxide. For example, storing apples in a controlled atmosphere combined with refrigeration increases their shelf life up to 10 months, compared to storage only with a refrigerator. So the combination of these factors, composition of the atmosphere, the modified composition of atmosphere with low temperatures will increase the shelf life of some products, like in apples, for 10 months, and this is a big fact. This is a big is important because creates you the possibility to have to storage in good conditions the product. Specific requirements of atmospheric parameters are also applied for the control and preservation of animal products, such as meat. Conservation of fresh meat prefers an atmosphere with high concentration of oxygen to maintain its red color, but at the same time requires a high concentration of carbon dioxide to inhibit aerobic bacteria. This type of controlled atmosphere used for storing food products should apply not only to warehouses but also to the transportation trunks of raw materials. Food transport is an important link in the food chain, as all food products, raw materials, fresh and processed products, are all delivered locally and globally, as well as by earth or land, by sea and air. Nowadays, customers expect a year-round supply with different products. Long distance and air transportation has become a commonplace. The importance of transportation is so great that it is often regarded as a continuation of the storage process. Two major issues of food safety during transportation are to be considered: protection of food from contamination and keeping at proper temperature during the transportation. Protecting from food from contamination is carried out using lid containers or other covered containers. The materials used to cover the food may be aluminum foil or plastic film, suitable for contact with food to ensure that they do not contain any chemicals that may leak into the food. Packaged products should not need any additional coverage. Temperature control. When transporting potentially hazardous food, they must be kept at temperature below 5 degrees or above 60 degrees during the journey. Alternatively, to secure the food, if this temperature cannot be used, other options should be considered, such as, if the journey is short, should be used insulated containers that can keep food cold. If the journey is longer, it is imperative to use ice blocks for low temperature and heat packs to keep food warm. The major challenges during transportation are to maintain the quality of the food during transport and to apply good logistics. In other words, to move the goods to the right place and to the right time, and especially in good conditions, because transportation is also subject to physical and mechanical stress.